What does it mean to be a logarithm function? Well, very, very generally, a logarithm function has an equation that looks like this. That looks pretty complicated, and it's got a lot of moving parts. So in first thinking about the graph of a log function, let's think about something a little bit simpler. In particular, let's think about just g of x is the log base b of x. What will this guy's graph look like? We could look at pictures the way that we did for exponentials, but instead, let's think about what we already know about exponentials. What do we already know about exponentials? We know what their graphs look like in general. But we also know that the log is the inverse of an exponential function. So if we want to graph y is the log base b of x, that's the same as graphing b to the y equals x. Now, we know what the graph of b to the x equals y looks like. It looks like this if b is greater than 1. It looks like this if b is between 0 and 1. How do we go from the graph of b to the x equals y to the graph of b to the y equals x? We reflect across the 45-degree diagonal. So we know, just in a very general way, what the graph of y equals log b of x looks like. When we reflect it, this horizontal asymptote becomes a vertical asymptote, the line x equals 0. When we reflect it, these points over here become points down here. These points over here become points up here. So, very roughly, very generally, if b is greater than 1, the graph of log b looks something like this. If b is between 0 and 1, the graph of log b looks something like this. Let's go back to what we have generally now and look at some graphs on the calculator and see if we can come up with some more. Let's see what the effects are of nudging what's inside the log and of nudging what's outside the log. So I have a green, a red, a purple, and a blue function. I have my graph set to give me a green, a red, a magenta, and a blue line. So the green function, how do I get log 2? On my calculator, I go here and select log base. We'll talk about what you might need to do on your calculator later. So log base 2, x minus 1. Here, log base 2, negative x minus 1. Here, log base 2 of x. Oh, I wanted to make that negative, didn't I? Plus 4. And here, negative log base 2 x minus 3. All right, let's graph this thing. So the first thing we notice looking at this graph is that the calculator doesn't really like graphing those vertical asymptotes. So it's a good thing that we figured out that they were going to be there, right? Because it looks like these graphs just stop. It's a good thing we know that those vertical asymptotes are there, or we would never figure it out from looking at this computer-generated picture. What else? The second thing we notice is that everyone is off to the right of their vertical asymptote, except for g. What's different about g? The negative sign on the x. The third thing we notice is that these numbers just move the graph up and down. These numbers move the graph left and right. And it looks like this one has its vertical asymptote at about 1. This one has its vertical asymptote at about negative 1. And one more thing. This negative sign up here, what does it do? It flips the graph upside down. Okay, we are in a position now to figure out what the graph of a log function looks like in general. First, let's figure out where the vertical asymptote is. This one had a vertical asymptote at x equals +1. This one had a vertical asymptote at x equals -1. I think in general, we'll have a vertical asymptote where whatever's inside the log is 0. And then if a is a negative number, we'll flip the graph vertically. Otherwise, we have 4 possibilities. If b is between 0 and 1 and c is a positive number, our graph looks like this. If b is more than 1 and c is a positive number, our graph looks like this. If b is between 0 and 1 and c is a negative number, then our graph lives on the other side of the asymptote and looks like this. And finally, if b is more than 1 and c is a negative number, our graph looks like this. Again, if there's a negative sign in front of the log, we've got to flip the whole thing vertically. And then, to figure out more specifics, we'll try to plug in values of x that make the arithmetic easy.